For as long as humans have recorded history, we've told the story of technology the same way. A steady climb forward, each generation building a little more knowledge than the one before. But sometimes, the past doesn't follow that story. Sometimes archaeologists uncover something, a fragment of metal, a gear, a carved mechanism. That forces engineers to step back. Look again. And quietly admit. This shouldn't exist for its time. Today, we're looking at 7 devices so advanced that modern specialists still struggle to recreate them. With the same precision, the same efficiency. And in some cases, the same mystery. And our journey begins in ancient Rome. Number 1, the Roman odometer. 2,000 years ago, Roman engineers attached a small mechanical box to the wheels of their wagons. Inside that box was a system of gears so precisely carved that it translated wheel rotations into distance measurements. For every certain number of rotations, a stone dropped into a container. A perfect mechanical counter. It's simple to explain. But to build? That's another story. Modern machinists, using steel tools and precision lathes, can recreate this device accurately. But for Romans with hand tools, to cut gear teeth this precise, with ratios this exact, means their knowledge of mathematics and mechanics was far more sophisticated than we once believed. And if this survived only as a description in ancient texts, what other machines did they build that never made it into the history books? Because the truth is, technology does not always evolve. Sometimes, it disappears. Number 2, the Greek water clock regulator. Ancient Greece was known for philosophy, architecture, and mathematics. But hidden in the ruins of old public squares is a device that reveals another kind of brilliance. A mastery of fluid mechanics. The basic water clock was simple. Water flowed from one vessel to another. But the Greeks didn't stop there. They engineered a regulator. A device that kept water flow perfectly stable. No matter the pressure, the temperature, or the starting volume. A floating valve, a finely balanced chamber. And bronze components working together in a precise feedback loop. This is engineering language we use today. But the Greeks were doing it thousands of years ago. Some horologists who study ancient clocks say the precision of this regulator rivals early European clockmaking. To recreate one now, engineers must calculate flow rates, pressure curves, and hydrodynamic stability. Yet the Greeks achieved all of this with bronze tools and raw intuition. Number 3, the Persian vertical axis windmill. Long before Europe built its first windmill, ancient Persia engineered a machine so advanced in its design that renewable energy researchers still analyze it today. Unlike modern windmills, these machines rotated on a vertical axis, ideal for turbulent desert winds. Inside stone towers, synchronized blades channeled wind through carved openings, turning a central shaft that powered grinders and pumps. To recreate this today requires aerodynamic modeling. Yet the Persians built these machines more than 1,000 years early, fully formed, with no clear evolutionary path. It's as if the design appeared suddenly, developed by engineers who understood wind behavior, torque, and mechanical synchronization far beyond what the records suggest. And just like that, 3 machines into our list, a picture begins to emerge. Ancient civilizations weren't simply using tools. They were mastering principles. Number 4, the Indian temple automata. Across ancient Indian temples, texts describe machines that moved on their own. Birds that flapped their wings. Figures that offered flowers. Doors that opened automatically during rituals. Most of these devices haven't survived intact. But the fragments that do exist. Tiny gears, pivot joints, rods, and bronze pieces. Show tolerances so tight that even a small misalignment causes mechanical failure. Yet these automata supposedly performed flawlessly in front of entire crowds. Some scholars believe this knowledge was guarded by specialized temple engineers, a lineage of craftsmen whose secrets vanished with time. If true, then entire branches of mechanical understanding may have existed in ancient India and disappeared completely. Number 5, the Chinese south-pointing spoon. Long before magnetic compasses, Chinese artisans crafted a polished bronze spoon that always pointed south. Not by magnetism, not by hidden internal parts. It worked purely through balance. Geometry so perfect that modern replicas require machine-level polishing to achieve the same frictionless motion. Ancient craftsmen with hand tools achieved optical-level smoothness without knowing the physics behind it. It is one of the earliest examples of precision engineering, and one that modern scientists still struggle to recreate exactly. Number 6, the Nabatean water automation system. Beneath the ancient city of Petra lies a hydraulic network so advanced that modern hydrologists compare it to an automated machine. Pressure equalizing chambers, surge control, sediment filters, temperature-stable reservoirs, self-regulating water flow that adapts automatically to the season. And they carved all of this into raw stone. 2,000 years later, parts of the system still function. To do this without metal pipelines, without modern tools, and without formal equations, requires an intuitive understanding of hydraulics that seems almost impossible for its time. Number 7, the Egyptian lifting spiral. Initially mistaken for decoration, this spiral artifact shows evidence of rotational wear, suggesting it converted circular motion into vertical lift. Its geometry resembles the Archimedes screw. Yet it predates Archimedes by centuries. Carving a perfect spiral with ancient tools requires precision so high that even modern reconstructions struggle with binding and friction. The fragments we have show almost flawless curvature. Uniform, mathematical, mechanical. Some believe it was part of a lifting system used in construction. Others think it belonged to a larger machine that has never been found. Whatever the truth is, it widens the gap between what ancient engineers were capable of and what we assumed they knew. Conclusion. When we step back and look at all 7 devices together, a pattern becomes undeniable. These weren't primitive societies stumbling through early technology. These were civilizations experimenting with mechanics, motion, pressure, balance, materials, and physics. Long before these concepts had names. Technology isn't a straight line. It rises, falls, disappears, and sometimes it returns centuries later in the ruins of the past. Thank you for watching. 7 ancient devices engineers still can't rebuild today. If you want to explore more forgotten machines, lost technologies, and mysteries of ancient engineering, make sure to subscribe, because the next discovery might be the most unbelievable one yet.